Hey guys, Joe Pye here at Advanced Innovations, Austin, Texas. Welcome back. It's been a couple of weeks since I've been online, and thank you to everybody that has come back. Welcome to all my new subscribers. I just crossed over 17,000 subscribers, and this is my first year online. So thank you to everyone that has inspired me to continue to do this. The feedback and the comments have just motivated me to continue to share what I know, and thank you for hanging in there. Second item of business, the DiCarlo family wishes me to thank everyone that has stepped up and sent them donations for my friend Joe's illness. He's currently suffering with cancer and it's not looking good, and I wish I had better news, but it is what it is, and time will tell exactly how this is going to play out. Lauren, his wife, wanted me specifically to say thank you to everyone because she has no avenue to do so. So thank you very much. If you still want to contribute, and God knows they need it, go to my website. There's a GoFundMe link. You know, for the cost of a beer or a pack of cigarettes, they could really use the money, especially now the medical bills are really mounting up. That being said, today I'm going to get back on the lathe and we're going to make a part. And there's going to be a hook here in a second, so check this out. This is not going to be a big deal. We're going to have a straight diameter on the part. Now let's say go to a 45. And another straight diameter. And I don't know, let's say what, a 30? Let's do that. A 30. I bet that's pretty close. Okay, now you look at that and you say, that's no big deal, right? Piece of cake. Well, here's the hook. That's the ID. Well, now it just got interesting, right? Well, here's your ID. Not only how do you cut it, how do you measure it? When you get beyond the initial opening in any part and you start getting internal features that you can't see, I call that blind work, and it's a very appropriate title because you might as well have a blindfold on because you can't see the tool, you can't get anything in there, conventional tools to measure it. And I'm going to show you a trick on how to set this up, how to know where your tools are at, and a very simple, very inexpensive way to measure it. Now, if you have a big shop and you have a big checkbook, you can buy Intertest, dial bores, you can buy a variety of different devices that go down inside of a undercut or a smooth cylindrical bore and measure it. But when you start getting into oddball stuff like this, it's a whole different animal. And you certainly don't want to go out and spend $1,100 on a set of dial bore gauges just to measure one piece. So I'm going to show you something that you could possibly actually even make. It would be a great project for you. So let's take a walk out to the lathe and get this going. I think you're going to like what you see. Okay, this is the part that we're going to put in the lathe, and we're going to bore out the inside per spec. There's a 1-inch 250 diameter coming in the front, 45-degree chamfer leading up to a 1-inch 510 diameter into a 30-degree down to a 1-inch 220 diameter through. Now, since the end decimal here is a 2-place and the print spec allows for deviation of 10th thou on that, I'm just going to drill that in, but everything else here will be bored. The coordination of the tool, we're going to use a single tool to do the inside. Now, naturally, if you have the capabilities and your shop is such that you can grind a form tool to do this in one shot and the material will permit that, by all means do that. But I'm going to show you the technique for coordinating your tools and getting your diameters and your dimensions clean and well placed. This is the instrument that we're going to check the major diameter of the undercut with. Relatively simple little instrument. Interchangeable tips based on the entry diameter that you're going to be passing through and the size that you're going to need to check. You can extend these. Naturally, they unscrew and you can put on longer tips, rounded tips, thinner tips. You can see the action of the indicator. This indicator will go all the way around and zero much further than it is. I'll show you. You can lift the tip here. So there's still travel on that. It's not maxed out. You don't want to max these out when you set these. The ideal configuration is to have the indicator tip straight with the indicator body. So this is not an ideal setup, but it's not so far from ideal that it's not acceptable. You can adjust your zero with these little thumb screws in the front. You can adjust the stroke of how much it goes beyond zero with this little guy right here. You want to make sure that when you squeeze it together that it fits in the bore that you want it to pass through. And since we're going through a 1-inch 250 bore in the front, I don't know if you can see that or not, but this will easily pass through the 1-inch 250 bore, and when it opens up it'll easily go to the 1-inch 510 that we're looking for as well. Now, in order to set this, just use a 2-inch mic, set it to your diameter, lock it off. They do make micrometer clamps that would come in real handy with this, and you can set the micrometer in the clamp. And one of the things I've noticed, if you're setting these a lot and you don't want your tips to walk off of the micrometer anvils, is put a piece of 1/4-inch tubing, a short piece of 1/4-inch tubing around the upper and lower parts of the micrometer, and they act as little cups and keep the tip from walking out. It makes it a lot easier to set these up. So once you have your micrometer locked into the size you want, walk this thing back and forth until you know you have your zero. And now, although this particular instrument is not a measuring instrument, it's an indicating instrument. That's why I say this might be a fun project to make on your own. This is strictly a pivot point. It's not a crossover pivot point. This is the same arm all the way through. It just knuckles down and goes into here. So the top arm is the only arm that moves. That would not be a big deal at all to make one of these, especially the way this one is made. A couple of side plates, make this from flat stock, have a pivot point, and there is a spring in here. It does want to return all by itself. But that is an Indi-Cal with that brown and sharp best test indicator on it, and it's held on with the little dovetail clamp down here on the side. Nice little unit, very helpful. I've had this in my box for gotta be 40 years now. Great little piece. If you don't have one, get one. It's very versatile, and it certainly can service a variety of sizes. You can see, I mean, you can just continue to put these extensions on here and you can check them any size you want. So long as you have a way to set it, you'll have a way to utilize it. All right, let's get over to the lathe and see what's going on. Just to make it easier to blend any large surfaces on your tool, it's a good idea to indicate the outside of your tool. If you're sure that the outside of the tool is ground true to the tip. For the sake of this video, and for the sake of your part, it's really helpful if you know how wide the tip of your tool is. This particular tool is 178 thousandths wide, and that's going to be very important here very shortly. First thing we're going to do on this part is to pop a 1-inch 218 or 732, 1-inch 7/32 diameter hole through the part. It's close enough to the 1-inch 220 nominal on the print. And you'll notice that there is no pilot hole. This is plastic, and it should go pretty quick. I chose to use plastic for this demonstration so that I wouldn't have to take too much time, run too much camera time, and just burn up a whole lot of unnecessary YouTube. So here we go. feature that's going to be the hardest to do on this part is going to be the 1" 510 swollen inside undercut. So I'm going to show you a trick that I like, and I think if your part permits it, it's something that you should remember for your own application. I'm going to take a much smaller bar. Actually, I'm going to take the bar I'm going to use to make the undercut with. Let's start there. My compound is already set at 45 degrees. The tool is true. I'm going to put a small counter bore on the front of this part that has absolutely nothing to do with the part, but it's going to be a size that I can measure. I'm going to go in approximately 100,000ths of an inch from contact. This is where you would zero your digital or your DRO or whatever you have. You're going to go on 100 grand. And I'm going to measure it. Okay, 477. We're 33 away from final. 3, 10, 20, 33. Back to 100. And double check the size. It's 506. Got to go 4 more. Let's say 4 more. I'm going to take a Sharpie marker right now, and I am going to draw somewhere on the machine so that I can reference this particular position as my final. Now, I will not check any of these dimensions with the exception of the lead bore until this part is done well, until it's done, so I can show you exactly how accurate this method really is. The lead bore on the print is 1" 250. Now the compound is still set at 45 degrees, but it has not moved yet. 1 inch 250, I'm very pleased with that. So we have our first diameter established. I know that a particular 100th thou depth on this counter bore right here, so I'm going to reset my digital readout to 0 so that all my depths are true from this point forward. True to the print. There you go. Now, according to the print, the back side of the undercut I'm looking for is at 755 deep. Now I'm going to move it in 755. Actually, I'm going to go 750. I'm leaving room for a cleanup pass. I like cleanup cuts. And I'm just going to pull back now to the dimension, the number on my slide that I used to do this counter bore. If you know what the counter bore is, which is exactly the same size as the undercut inside, you just need to pull back to the same number without moving the compound. Now, knowing that the other dimension on the print is 380, you're going to take the thickness of your tool and you're going to add it to that 380, and that'll be the depth of the next cut. .558 it is. And back to the number that you used to do the front counter bore. You can put your finger down inside and feel if you have a rib left. If you do, shift the carriage accordingly and knock the rib off, because the last thing you want is a washer floating around inside that undercut. It's a good way to burn up or break a tool. I wish this part were clear. You'd have a better idea what's going on here. But the last one was 558 and the first one was 750. So I'm going to go 650 for the center tool. Center pass. Now I'm going to sweep it so that it's a nice clean diameter. Starting at the 558 depth, which is the 380 on the print plus the 178 wide tool. Let's see what we get. .558. Going for the 755 depth on the print. And we'll move in using the cross slide. Now, although I could go inside here right now and check that diameter, I'm not going to. I'm going to trust this technique, and hopefully it's not going to let me down when push comes to shove. I'm going to go back to the starting position with this particular tool right now, 558 on my digital. And I'm going to once again return the tool to the position where it cuts the main diameter. At that point, I'm going to use the compound set at 45 degrees, and I'm going to draw this tool out, and I'm going to put the 45-degree feature on that leads in from the diameter that you start with to the larger undercut. See how that works out. Once you're clear, pull out. I like it. Okay, give me a couple minutes here to reset the tool for the inside 30-degree angle, and we'll show you how to do that. When you start a job like this, make sure that your cross slide is on 0. Let's see if we can shade that. Make sure that you have a Sharpie marker reference point that indicates where that 0 is. I always like the front of my compound flush with the stationary base, and I just use the base length as my 0 reference point. And when I bored not only the front 1" 510 but the inside 1" 510, I put a Sharpie marker line right on the casting, and I wrote the number on the casting that the dial needs to be returned to. Now make sure that when you're working internally that you don't get all excited about the feature that you just cut and drag the tool out and wipe out the boss on the front of the part. I'm going to set the compound now for the 30-degree angle to be cut here, and then we'll figure out exactly how we're going to pick that up. I'll bet you this 1" 510 counterbore on the front of the part really is going to come in handy here in about 2 minutes. Stay tuned. Okay, before we get back inside that part and cut that trailing edge 30-degree on, let's review exactly what you're looking at in case any of that moved a little bit too fast for you. This is a cross section of the part. This is the center line of the bore. This is the 100 thou deep tooling diameter that I put on the face of the part so that I knew where the undercut diameter would be. Now what we've done is we've taken the 178 tool, registered our 0 face, and found the 1" 510 diameter that we needed, came in, plunged the back, plunged the front, knocked the web out, then I swept the part. Now naturally, if there's a 380 on your print, if you're trying to hit this bottom corner, you have to add the thickness of the tool to that. So 558 was actually where this tool stops, because the front of the tool is 558 from this surface right here. Then with the compound set at 45, I drew the tool back out and I formed the large undercut and the 45 all with one tool. Now you could do that a different way if you wanted to. You could use a tool that already had a 45-degree angle on it. But like I said before, it's really important to know what your tools look like, the angles, the widths, everything. So it would be a little easier to come in, hit your mark, sweep back to your dimension, and the tool would actually give you the 45. So there is no compound out. In this situation, you can have your compound already set at 30, hit your 45, sweep your groove, and now compound out the 30-degree, and you could do the entire thing with one tool. This would be a form tool. If this was a CNC job, you would do it with a profiling tool. The profiling tool would come in and create the bore, step down on the specified angle per print, create the undercut, and run out, all naturally CNC controlled. The angle on the insert that you would use would naturally be less than any of the feature angles because you do not want a large surface contact if it's a considerable land down inside the part. So the machine's already been set to the 30 degrees. What I'm going to do now is we're going to go back out. I'm going to find the location for the tool. I'm going to move in. We're going to drop the tool right down in this corner and compound off this 30-degree angle right there. And I'm going to chop the part in half so you can see what it looks like. Let's take a look. Okay, for this operation, the compound has been set to the 30 degrees. Same tool. We're going to go in and bump on that 100 thou deep face, and we're going to pull out until we just dust the 1-inch 510 lead diameter that we have on this part. And that's going to give us a very important registration point for positioning this tool for the internal 30-degree chamfer. Right there. So let's reposition the camera, get it stabilized, get this done. Okay, I've set the camera at such an angle so I hope that you can see what we're trying to knock off, and it would be this square corner down in here that we're trying to hit. We're going to bring the tool in. I'm going to bump the 100 face. Since we did shift the 45 to a 30, we've lost all our locations and we have to relocate this. So I'm going to go to 100. Gentle bump. I'm going to zero my digital, but this is where you would zero your dial indicator, drop indicator, travel dial, whatever you have. I'm going to back it off, and since this is plastic and there may be some compression, I'm not going to trust that that zero is actually surface zero. So I'm going to creep up on it with the machine running, as well as try to hit the diameter and come up with the number on my cross slide. If this part were metal, you would put Dykem or hit that with a Sharpie marker and just watch for the line to disappear. Okay, 192 is the number. Gonna move into the 755 on the print. I am going to draw back to the 192 number. On the cross slide. The tool should be sitting right in that bottom corner. Right now. Now I'm going to 30 degree out. Although the chips are getting in the way, let's hope there's a 30 degree trailing edge feature being formed right now. I'm going to position the tool visually to the center of the part so I don't knock any of the other features off. Out we go. Okay, you can see down inside the part there's a nice clean 30 degree land in there now. And this is a good time to check it dimensionally, so I'm going to zoom out a little bit. Let's change the camera angle. Let's see what that 1-inch 510 undercut really looks like. This is the Indi-Cal that I set up previously, and I'm really hoping this is in frame. I'm I'm going to compress it, get over the 1" 250 in the front, and we're going to look for 0. Make sure you're not sitting on any of the angles. Rock it back and forth, look for a high spot, and then sweep it this way, look for a high spot. Guys, I would say that's pretty close to almost spot on. I am very pleased with that. I'm going to compress it again to pull it out. There you go. Let's cut it in half. Well, there we go, guys. That's what the final part looks like after we split it. And I'm sorry I couldn't get the actual cutting operation. It's really not a big deal. But you can see that you have your nice 1" 250 lead, 45 degrees up to the 1" 510 undercut, 30 degrees through to the drilled hole. And that is a really good way to do that. The counter bore reference diameter I turned on the face is gone, and you just would not know. Now, it's not necessarily as helpful for the initial 1" 510 with the 45, but when you go back in there to make contact with the internal diameter and blend your tool out for the second op, it is a great reference tool for coordinating different features inside the part that you can't see. So instead of ruining a nice diameter that you had on the inside, you can make contact on the outside, feed it in, do all your math, and complete the part accordingly. But there you go. Non-CNC internal blind work, 2 angles, 1 giant internal undercut, and the whole thing is within 2/1000 of an inch. Hope you like it. All right, guys, well, I hope that you enjoyed that. Blind internal work is challenging, frustrating, but it's very rewarding when you actually pull it off. I would think that one of the most important features of any type of blind internal work is that you take your time when you set up, mark up your machine, know where everything is at. Don't be afraid to take a Sharpie marker and draw all over your compound and your cross slide and just whatever you got to do. You're definitely going to need a digital readout or a long travel drop indicator or a travel dial or some way of tracking your carriage movement, of course. The tools that you just saw me use, the little measuring device was called an Indi-Cal. You can still get them. They're about $200 if you find them. Tom Lipton over at Ox Tool did a review on that particular instrument. I guess it was about 2 or 3 years ago in one of his videos. So big shout out to Tom Lipton at Ox Tool. This is a great combination to have in your arsenal, and that particular tool, you could probably make it because it doesn't have to be very precision, just very repeatable. So who knows, it might be a good project, knock one out. Clearance on your tools is very important. Make sure that as you dial in any angle on any tool internally, that you have the clearance on the tool or the protection of the cutting edge is sufficient for the feature that you want to cut. I hope you like what you saw. It certainly is an interesting thing to try. So grab a piece of stock, grab a piece of scrap stock, whatever, grind yourself up a tool and have at it. It's a lot of fun, and I hope your results are favorable and you like that little counterbore trick as well. That's a good way to preset a tool without actually having to make contact inside your part and screw up your features. Anyway, that's all I got. Joe Pye Advanced Innovations, Austin, Texas. I'm out.